Hello everyone, I'm Xiao Gang. Now let's start writing our code. As you all know, our approach is to build from the bottom up, right? Let's begin by writing the most basic interface. Obviously, we need such an interface, right? This interface is also very simple. Pay attention. Here we no longer use the C language style. We use a C++ container because, so if we use this again, it's still a bit tricky. A little tricky because it feels like a tearaway effect. And here it actually stores pointer. What I want to explain to you here. Here we need to include the vector container. Okay. After including this container, we create its implementation. Let's copy this down here. Let me explain what these parameters mean. Obviously, let's explain them in reverse order. This is the quality, image quality. The better the image quality, the higher the quality, the larger the size, the clearer it is, right? And this is the width and height of the image. No problem. This is the X and Y, right? And this is each frame. Because it's an animated image, you might have 100 or 200 frames. So this part records the timestamp, and then each of your frames corresponds to a segment of pixel data. So here we stored the pointer. You can see we stored this pointer here to avoid too much copying, because animated images are actually quite large, right? Calculate based on these pixels. We can knock up a calculator for it. We have 1920 times 10,080 times 4 bytes. So it's actually this many bytes. Then we divide by 1024 and then by 1024. Right. So for one image, it's roughly this big. Let me double check. Right. It's exactly this big because it's raw data, right? Yeah, about 8 megabytes. But after it is compressed according to a specific method, it actually won't be this large. Then click on 1920 by 1080 again. 0 then multiplied by 4. Because we are using RGB, then we divide by 1224 and then by 1024 again. The original data is probably about 8 megabytes. This is indeed quite large. This part is equivalent to, if our resolution is 1920 by 1080, then this pointer might point to this memory area. It might be a byte of this size. Yes, and here the time is stored. Okay, now let's write the code inside. Okay, let's write the solid line here. And you need to take a good look at this, because you might look for others across the internet. You can also find a lot of knowledge about BSP online. For example, right here, we have actually prepared a copy for you as well. However, these things, you should already have this document. There's a lot of BSP here. But when you use this in Unreal Engine, actually, when I was working on this back then, it was basically very hard to find anything usable online. I pondered over it for a long time. Only then did I figure out that this approach could work. Okay, then we have a return false here. Here we return true for this part. First, ensure it can compile and pass. This part can definitely return some status conversion and log information. The reason we don't do it is because we want to maintain purity, and many places can be optimized or have pending issues. There is just no time to verify. Okay, first we give up quality judgment first, because we still need to limit it, because some people might directly call the API. So let's limit it. Then we determine it here. The current number of RGB images must match the number of times. They must correspond 1 to 1. Otherwise, we will give a false. Then, in this place, we declare an object. This object is called webconfig. This object can be configured with this information inside, such as quality, method, and some other stuff. Anyway, it's just a bunch of parameters. If you're interested, take a look, because this course of ours is not about teaching web app. Our core focus is not to teach you how to encode PNG, how to encode JPG, how to do it app. This image keeps rotating. We won't talk about this. We are just using this case to learn this thing in UE5. It just so happens that we have this set of things that aren't available on the market. We'll just borrow this thing from it too. So we need to distinguish the main points. So here you can see there are so many helpers, and after having these helpers, then these configurations. Then we need to initialize this configuration first. Many C languages like to write it this way, and this is always Q. Then initialize a wave config structure. Then before starting to use it, this must definitely be initialized successfully, right? Then this usually also provides some default values. We can make some adjustments by default. We'll just leave it alone. Then after this initialization is complete, we declare an encode because we now need to encode this animation. Similarly, we also initialize the encoder. You can see this is an encoder. Let's take a look. Galber optation also goes to encode the animation. Then there must be something like keyframes or mix some of these things together. We don't care about it. We mainly look at this. This is also an initialization. You need to, before modifying, initialize this encoder. Okay, after these two steps are fine. For the encoder, we set some default parameters for it. The parameters annotation is right here. It actually involves our audio, video, and images. That is how it defines these keys. How to convert this information into some judgments. Okay, we don't actually care about this. It has some rules here. For example, max is greater than man. Also, man must be greater than or equal to max divided by 2 plus 1. At the same time, there are some judgment principles here. Okay, we don't need to delve into this, right? Okay, then here we configure this encoder. We just need to configure the global configuration. Then here we have some losses, things like that. Then focus on this marker 1. You'll see we selected marker 4. And here you can choose fastest or slow, beta, things of that sort. We don't care about this either. Okay, this place. This is the quality parameter we passed in, ranging from 0 to 100. These are all imitation parameters, ignore them. Then here we take this enemy option. Take another look at this thing. Reinitialize it. Yes. Okay, after we have these two configurations ready, we go down. Then at this point, we create an encoder. Yes, once we have this option. We create an encoder. This should be the standard encoder, right? This thing, yes. Okay, then we pass in this width and height. Then these objects should be hidden. This place, there was a problem with the code before. If it's not corrected, just leave it. Then pass this configuration to this place. Then next we will start inputting our data. We will start executing this operation from B1 to B10. First, we set this time as the start time. Tell in point time. Then we find these two pointers. We get this pointer to the first address, right? This place, because it's a vector. We get the pointer to its first element like this. After getting this pointer, we start a loop. Then, during this loop process, so we use a for loop, as long as it doesn't, because we already determined earlier that their sizes are the same, so it just needs to iterate until the end. Then it must be an iterative process. During this iterative process, we need to input the images, frame by frame. So here we declare an image structure for this frame. And then we perform a simple initialization of this image structure. Actually, only the structure is declared here. You can see this thing is quite complex. Everyone needs to look at it in detail because you declare and then release. That is again, and also you need to specify that it is an RGBA format. Or this YUA format. Okay, so on our side, it's equivalent to declaring this structure and then allocating some memory space for it, etc. Then we indicate that it uses this RGBA format. You can see here, this is a flag. Which format is actually used? Obviously, here we are using RGBA. Then next, we copy the width and height over. The width and height can be copied over. Then here, it is a stride. This stride must be passed like this. Yes, you must multiply it by 4. Only by passing it, this way will it work. Why is it multiplied by 4? Because it should be related to the scanning mechanism of that kind of image. So it scans once, it's just scanning 4 at a time. Scanning 4 at a time. So it's multiplied by 4 like this. Scanning row by row like this. I vaguely remember it being like this. As soon as you see it, emphasize that this is not bytes. This is stride in the pixel unit. It's about how to scan the segment of pixels. So this must be passed here. This thing is very important. Very important. This issue of multiplying by 4 and multiplying by 3. You need to look it up on English websites to get a detailed explanation. Then, after scanning this, it's equivalent to this memory area of ours. The information inside it has already been prepared. At this point, we import our data. How do we import it? Here, we first find our one picture, and our data is exactly this. Memory area pointed to by this pointer. Then you can see the parameter passed here is the RGBA array. Then you just scan it in like this. It will take all the data of the pixels from 1920 by 1080 pointed to by this pointer and dump it all into this picture. Then at this point, we add our time point. Adding this, adding it in, which is equivalent to adding this step length. After adding it, we add this image to our system. This is the V1 image. This is something we can know at a glance. Xiaomi Carter know at a glance. Once T clicked, this encoder is triggered. And then this web picture is equivalent to us creating this image. And this image is its time node. And this web picture configs is the data of the config we initially specified. Then this is generally done. After it's done, it's not finished yet. Let's release this image. Okay, released. Okay, so this means we have completed the step from B1 to B10. It's still quite clear. Then finally, we add an end frame. We add a blank end frame, end it. Then finally, we have just organized our stuff. Finally, we output it. It's just like doing PS. You finish everything in your project. Finally, you need to output it. Then you prepare a web data. After preparing the web data, then you take the mathematics of the dynamic image in the encoder you assembled and stuff it all into this data. That's done. Finally, we delete this encoder. The resources of this encoder are reclaimed. After deleting it, we perform the same operation as before. We create AC VPAC input stream. While input stream, we just need to take the assembled data, its bytes and size, and input all of it, then close it. And finally, regardless, we all need to go. If it succeeds, you will release this resource, right? So actually, if you don't succeed here, we give this an AOS. That means your stream opening failed. Then you also need to release this resource. Yes, then just give it a force. Okay. Then we layer up and down. We have finished cleaning up this underlying interface for everyone. You can see there are some comments in places. We don't need to worry about them. This is because you can enter these warnings. We can use this to suppress the warnings. So let's suppress this warning. Let's put it here. Put it up here. The top should be able to suppress this warning. Take a look. It seems it doesn't seem to have suppressed it, but let's ignore it. Anyway, it's just a warning level message. Sometimes, just like when we import third-party libraries, it usually produces some similar issues. You can check the documentation and refer to the solutions. Okay. Let me show you one more time. Once we finish writing this interface, we won't touch it. Then it can be used externally. And this interface we did not export. It is only allowed to be used simply within our own module. Okay, then let's review again. Review. This is the initialization, some config of this libwebp and a configuration of the animation encoder. Then this part here is equivalent to operation A. This is operation A. This is operation B1 to B10. And finally, this is operation C. Just return the data. Okay. We'll start writing other code in the next class.